Hi folks, we're going to spend a few minutes talking about the difference between heat and temperature. There's just a couple subtle points I want to make sure everybody gets. Now, temperature, as you know, is the average internal energy of the molecules in a substance. Heat is the total internal energy that is within an object that it can give to something else. Remember, heat flows, and the amount of heat in something depends upon the number of molecules, the temperature of them, the kind of molecules, and their state, solid, liquid, gas. So let's go through some examples because I want you to kind of ponder these questions in your head. So I've got two pictures here. Both of them are, let's pretend, exactly 1 cup of plain old beautiful H2O water. One is at 100 degrees Celsius and one is at 20 degrees Celsius. So think on this. Which one has a higher internal kinetic energy? Let's call this one A and this one B. Which one has a higher internal kinetic energy? Right, A, because internal kinetic energy is a measure of temperature. So they're both water, they're both the same amount of volume, higher temperature, higher internal kinetic energy. All right, which cup of water contains more heat? Same cup of water, same as water, different temperatures. Which one contains more heat? Sure, this one. Think about that. This heat can flow. Which one, let's say you had cold hands and you wanted to warm your hands up by putting them around one of these cups. Which one contained more heat that could flow into your cold hands? Well, of course, this one does. It has a lot more heat than the little cup of cold water, but it does contain some heat. All right, let's talk about a different situation. I have my cup of 100-degree water, and now I have a bathtub full of 40 degrees Celsius water. That's just a smidge above body temperature. This would be just a really nice bath temperature. So which one contains molecules of a higher internal kinetic energy? Which one? Yeah, the cup of water has got a higher internal kinetic energy because that's the definition of temperature. Okay, you know what's coming. Which one then contains more heat? 1 cup of 100-degree water or a bathtub full of 40 degrees Celsius water? Now think about this. Remember, heat flows. Which one of these, the bathtub or the cup, contains more heat that it can give to the surroundings? Let's say that you are locked into a small room like the bathroom and the heat is out. Which one will help warm the air the most overnight? Well, of course, it's going to be the bathtub. Another way of thinking about it is how many times would you have to use the cup to fill up that bathtub? Many hundreds of times probably in order to get that bathtub full of water. So it would take lots and lots of cups to make up for this water, even though it is less than half the average speed. All right, the questions are getting trickier. Which has a higher internal kinetic energy? My bathtub full of water or Lake Michigan, this is Lake Michigan, at 1 degree Celsius. Which one has a higher internal kinetic energy? Right, this one, because this is the definition of temperature. Which one contains more heat? The bathtub of 40-degree water or Lake Michigan at 1 degree? Yeah, this is tricky. Well, this bathtub, think of it this way. How many bathtubs would it take to fill up all of Lake Michigan? Chicago is down here. Milwaukee is down here. Green Bay, home of the Packers, is up there. This is a big lake. Now, it only might be at 1 degree Celsius, but because there's such a huge body of water, this contains so much heat that it affects whole climates. And we'll talk about that further in this chapter. But next to big bodies of water, the climates are unique and different and warmer because of the heat contained in those big bodies of water. All right, that'll do for this time. And we'll see you later. Bye-bye.